On the definition of statistics, so we continue. So in other ways, we can also define as it is a set of scientific, don't forget this word here, principles, meaning there are certain guidelines that you have to follow, or rather we can say techniques that are useful in reaching conclusions about populations. You people, you need to understand this introduction of whatever you're doing, because everything that we'll be doing further will be coming from this, right? As I said, what it means is statistics is where you have, let's say, a population, right? You have a population. Let me give an example here. You have a population, okay? You have A, you have B, you have C, you have D, you have E. Let's say this is your population, right? Now the fact is that the population is too big. You can't use a population to study everything that is in there. You get it? So what you do is you are going to get some things from this population, and when you get those things from the population, meaning you are collecting the data, and you are going to have a small of from the population. You get, meaning this small of, we call it a sample. It will be easier for you to work with it, and using this small thing that you have, you can make a conclusion about the entire population. So this is what they're trying to say. So we are trying to use, to reach certain conclusions about the populations and the processes, not just, let's say, and processes when the available information is both limited and the variable. As I said, you can't really manage dealing with the population, but you just have to collect the data. Then from the data, you make a conclusion. So that is statistics as well. In simple terms, we say statistics is the science of learning from the data. Exactly, learning from the data. For example, after 10 years, what do these people do? They conduct what's called census, right? That census in here, we call it a population. What do they do? How many people are there in Zambia? They will assume to say we've counted everyone in Zambia, but no, it's not everyone. They just deal with a certain part of Zambia. Then from that, they'll make a conclusion to say we are 20 billion and so forth, 20 million and so forth, something like that. But necessarily, it is not like we are, but we're trying to make a certain conclusion about the population by collecting the data. Not really exactly. So very, very soon we'll look at the terms that we use. So in statistics, in most of the cases, we deal with estimates. We don't really know what is exactly in the population. We just estimate. We proceed. Other point is saying we approach the study of statistics by considering the 4 steps as you are learning from the data. You are learning from the data, the ones you've collected. So it's either what you are learning from the data is making sense or it's not making sense. What will matter is how you collected your data, how you presented your data. Remember, at last you have to interpret your data. So what will happen is sometimes you may make errors and so forth. That's about the statistics. So we approach the study of statistics by considering 4 steps. Very important. Number 1, you have to collection of the data, right? You have to apply certain scientific methods for you to collect that data from the population. You always collect data from the population of your interest. Very soon we'll introduce something that will be called a target population and a study population, and you'll see the difference. So from that population, you collect the data. Then from that data, that's what I'm saying, it is the first step, and this is the foundation upon which the entire data set lies. Carefully planning is essential before collecting the data. So before you start collecting the collection of the data, you have to plan. Okay, how am I going to collect the data? Which people am I going to involve? What type of data am I collecting? Is it quantitative? Is it qualitative? Fine. If it is qualitative, is it discrete or continuous? Those stuffs. That's why I say careful planning is required when you're trying to collect the data. When you collect the data, the second step is you have to present. So what I'm saying is, how would you present that data? You've collected, yes, you've collected your data. Fine. But how do you present? The mass data collected should be presented in a suitable, concise form for further analysis. Now, on the presentation of the data, very soon where you're going, I should be lecture 3, we'll be talking about frequency distributions, pie charts, bar charts, histograms, everything will come here. What we're trying to say is, when you have your data, you have to come up with a way of you making it it's suitable. It will make sense for other people to understand, to say, oh, this data is talking about this. And there are methods that we use on this part here. There are methods we use here on the presentation of the data. And on the presentation of the data, when you're presenting the data, the key thing is the type of the data that you've collected. So there are certain methods, as we've said, we say these are scientific methods. Don't just do these things anyhow. We have to follow some scientific methods when you're presenting this data. Then after that, when you present your data, let's say it is in a pie chart, in a frequency distribution, a bar chart, and so forth, line graphs and so forth. The third thing that you have to do is the analysis of that data. How do you analyze the data? Analysis of the data means you're extracting the important things from that data. What can you see? That's analysis. You're extracting those valid information. So they're saying the data presented should be carefully analyzed for making inferences. But when that inferences, you people, as you're coming in, there's a branch of statistics called inferential statistics. The purpose of you analyzing the data, you're extracting the important things because you want to make a conclusion. You want to infer that data to the population that you've gotten that data from. That is inference. You're making a conclusion. Okay? That's the purpose of analysis. Analyze the data. What do? You are getting important things. You get that? Then you make a conclusion to say, oh, this population is skewed to the right. No, it's a normal distribution. No, these people do this and this. That's analysis. Then the last one is you have to interpret. You have to interpret the data. This is the final step. This is now you draw conclusions. Here, you're trying to extract important information. That is analysis. Then interpretation is now you come in as human. Maybe sometimes you may use a computer. There are things that like software like my SPSS. You can use that to help you interpret the data and so forth. But sometimes even you can, as human, you can interpret the data. And saying this is the final step. You're drawing the conclusion from the data collected. A valid conclusion must be drawn on the basis of the analysis. So meaning from the analysis, that's when you can come up with a valid conclusion. So this is all about statistics. So trying to learn from the data that you've collected, okay, from the population, right? Then you make a conclusion. Always at the end, you're making a conclusion. Then it goes like that. So very soon we'll talk about probability. There's so many things that we use in statistics, and yeah, very simple stuff that you understand them later.